Hi, I'm Dr. Hay, and this video is about the vector nature of Coulomb's law. So we have two stationary point charges, and they're each described by the position vector r1 and r2, r1 to q1 and r2 to q2. The force exerted by q1 on q2 is written this way. F12 by q1 on q2 is equal to the Coulomb's constant K times the charge of the first one times the charge of the second one. This is all over the distance r12. You may be wondering what r12 is. We'll get to that. Squared times r12 hat. So let's go back and discuss what this r12 is. R12 is the distance between our q1 to q2. So we're going to write it like this. It's a vector because we're talking about the vector nature of Coulomb's law in this video. So this is r12. It's a vector, just like these two are also vectors. So r12 can also be written like this. It's the second position vector minus the first one. And the length r12 is the magnitude of the position vector's difference. So here we have this r hat. Now what is r hat? R hat is the part of this equation that contains the vector. It's the direction. Here's the magnitude. So this is the magnitude. And this one is the direction. So r12 is defined as the direction pointing from q1 to q2. To q2. So in this example, it points from q1 to q2 across like that. Okay, K is the constant. That's the Coulomb's constant. So also, interestingly, by Newton's third law, we know that there's an equal and opposite force. So the force F12 is equal and opposite to the force F21. So we can say that there's a negative sign between these two. In essence, what that negative sign does is it says there's a force that's pointing in the opposite direction. So if F12 is positive, then the force points in the direction R12. It points from 1 to 2. So remember, we're finding the force by Q1 on Q2. So in other words, what Q2 feels, if we want to use those words. If F12 is negative, then it points in the direction negative r hat 12. So opposite that direction, so this way. So in other words, Q2 feels itself being pushed away if this is a positive, and it feels itself being attracted to Q1 if it's negative. And that's it for the vector nature of Coulomb's law.